Okay, we got an air traffic control tower spots an airplane at flying at a level altitude of 1,900 feet from the top of the 200-foot high tower. The air traffic controller measures an angle of elevation up to the plane, 24 degrees at point A. All right, so we got this beautifully drawn illustration here, but hey, there are no right triangles in this picture yet. I got this funny trapezoid down the tower, across the ground, up in the air to the airplane, and then we could cut straight across the green line back to the tower. That would make a trapezoid, or we could go across the sky to point B and then down to the tower, which um, also makes a trapezoid. Either way, it's not a right triangle, right? So we need to add a line. I'm going to extend this. Try to give you some hints in the illustration. I'm going to extend that line out so that I do have right triangles. I have at least one: the green side and the height, the red side, and then we'll go straight across at the level of the eyesight for where the air traffic control people inside the tower are. Right. So if the tower is 200 feet tall, the airplane was 1,900 feet off the ground. That means the difference in heights is going to be 1,700 feet from the top of the tower up to the airplane. So I'm going to work with that. So I got 1,700 feet as my elevation. I do have one right triangle drawn here with the green side, the pink side, and the black line I just extended across the sky. And that, sorry, I got to keep track of my answers here. We're going to put in that elevation there, 1,700 feet. How far away is the airplane from the tower at point A? So distance, we don't measure like diagonally, which I mean, maybe we should, but that's not the way we measure distance. So I want to know, like across the ground, how far would I have to walk from the tower across the ground to get, oh, the airplane is straight above me. Okay, that's the distance we're after. So I'm going to create two triangles. I need two triangles. It's a double triangle problem. It doesn't look like one. It looks weird, but I'm going to create two triangles. Okay, so here are my two triangles. I'm going to drop an invisible line down from the airplane at point B to create a blue triangle from the top of the tower across the air at the level of the air traffic control eyeballs, and then up the 1,700 feet additionally to where the airplane is at point B. There's my blue triangle, and I'm actually starting in point A, which is the green triangle here. Same idea across the level of the air traffic controller eyeballers up 1,700 feet to the airplane at point A. So I do have two triangles. It is a double triangle. It looks different because the way it is drawn, those two triangles do not share a common side. But that's really just the way it was drawn. The 1,700 feet is the same. If I take these triangles out of the diagram, then they are both going to have the same height of 1,700 feet. And so we could, at this point, if I take both triangles out of the diagram, I could put them back together so they do share a common side. I'll show you that in a minute. To answer the question, how far away is the airplane from the tower at point A? So from the tower at point A, I am going to turn this into my little stick person. There I am. That looks like my little stick person's got a ponytail and a skirt, I guess. So opposite and adjacent. Opposite is 1,700 feet and adjacent. I don't know that. I labeled it as an X. So my two choices are either tangent of 24 degrees is 1,700 over X, or I can use cotangent. You could actually do either one. I chose to use cotangent because I'd rather have the variable in the numerator. So I evaluated cotangent 24 multiplied by 1,700 and got about 1318. The directions over here say to round to the nearest whole foot. So actually I got 3,818 point like 2 or something, right? So it rounded down to 3818. And then I should enter that before moving on. 3818 rounded down to the nearest whole foot. Okay, so now after continuing in level flight, that means the elevation of the plane does not change. to point B, the angle of elevation to the plane from the same tower is 36 degrees. How far away is the airplane from the tower at point B? Okay, so here's point B, and again, I'll modify this letter into a stick person somehow. It's a head and a beer belly or something. Anyway, I don't know. There's a stick person. This was maybe not the best idea. I should have just drawn a stick person. So 36 degrees, and from the perspective of my stick person there with the head filled in, there's the opposite side. I can use a different letter for the adjacent side, so it's not they're not both x. I called it d this time for distance. And I had two choices. I can either set up tangent or cotangent. Again, I'm going to go with cotangent because I would rather have the variable in the numerator. So 1700 multiplied by the cotangent of 36 degrees, and I got 2340. This time I did have to round. That's not the right answer to show you. Let me catch back up. Multiplied by 1700. And this time, so I got 2,339.8. So I had to round up to the nearest whole number because the directions again tell me to round to the nearest whole foot. So that turned into 2,340. And at this point, I can demonstrate this illustration. I do still have a double triangle problem. It does look different, but if I drop my two triangles on top of each other, they do share that common side of 1,700 feet. Totally still a double triangle problem. If I find the surface distances, I'm still subtracting to find that difference. Okay, let me put the illustration back together. 36 degrees should fit right in there. Okay, then I have my two distances. So let's enter that distance in here before I move on. 2,340. And last question, how far away is the, sorry, that's not the right part. How far to the nearest foot did the airplane fly? Guess I'm just going to subtract those two distances. 3818 minus 2314 got a difference of 1478. It's already been rounded to the nearest whole foot. Boom, they're all correct.